Okay, so in this video, we'll consider the following problem. We want to find all points on the curve given by this equation, so x squared minus xy plus y squared equals 75, for which the tangent line is 1 horizontal, 2 vertical. Well, a horizontal tangent line has a slope of 0, hence we're looking for points in 1 where the derivative is equal to 0, and 2, well, a vertical line has infinite slope, and we'll see that when we find the derivative, it will be a fraction, and a division by 0 will give us an infinite slope. So all we need to do first is find the derivative. As always, we think of y as a function of x, and we can differentiate both sides with respect to x, since both sides are equal. Well, let's differentiate both sides carefully. So here, the derivative of x squared, that's simply equal to 2x, minus, here we have to open our brackets because we have the derivative of a product of x times y. So we use the product rule. Derivative of x is 1 times y, plus x times the derivative of y with respect to x, so we get x dy over dx, plus the derivative now of y squared, chain rule, we get 2y times the derivative of y dy over dx. That equals the derivative of the right-hand side. 75 is a constant, so its derivative is equal to 0. As always, let's now isolate dy over dx on one side of the equality. So if we distribute here the negative sign, we'll have that 2x minus y minus x dy over dx plus 2y dy over dx is equal to 0. So let's send these two terms on the other side, and we'll factor at the same time from the left a dy over dx. So we'll have dy over dx times, well, let's write the positive term first, so 2y dy over dx minus x dy over dx. And now we send these two terms on the other side, so of course they become negated. So negative y becomes positive y, minus, because positive 2x will become negative 2x. And now we have on the left-hand side a multiple of dy over dx. We can isolate dy over dx by dividing by this term on both sides. Therefore, the derivative of the curve dy over dx is y minus 2x divided by 2y minus x. And there you have it. Now we have the derivative of the curve for any given value of x and y. Now that we have the derivative, we can answer our two questions. Let's start with I. We're looking for points on the curve where the tangent line is horizontal. As we've said previously, a point on a curve will have a horizontal tangent line if the slope is 0, hence the derivative must be equal to 0. Well, our derivative is a fraction. The only way a fraction is 0 is if the numerator is equal to 0. So y minus 2x must be equal to 0. And now think of it. That's not the only equation that we have to satisfy, right? We're looking for a point, so an x and a y value, where the derivative is 0, hence where y minus 2x is equal to 0. But the points we're looking for also must be points on the curve. So the given values of x and y that we may find must also satisfy this equation. So we have to solve these two equations simultaneously, right? We're looking for points on the curve. Well, the points on the curve are the solutions to the equation that defines the curve. So this equation has to be satisfied. And because in the first problem, we look for horizontal tangent lines, our points, so the values of x and y, must also solve this equation. So we have to solve simultaneously this and this equation. Well, if you rewrite this one as y is equal to 2x, you can now substitute y by 2x in the equation of the curve. Let's do so. So what do we get? Well, x squared stays x squared, minus x times y, but y must be 2x, plus y squared, 2x squared, and that equals 75. And if you notice, what we have now is a quadratic in x. So let's solve for x, and then we'll solve for y. So what do we have here? Well, we have x squared minus 2x squared plus 4x squared equals 75. So x squared minus 2x squared is negative x squared, plus 4x squared gives us 3x squared, and that's 75. Well, divide by 3, so x squared is equal to, well, 75 over 3, but that's equal to 25. Right? 3 times 2, 60, plus 3 times 5, 15. 60 plus 15 is 75. Hence, x must be plus or minus the square root of 25. Always be careful that when you square something, you lose the negative sign. So you always get two solutions. But root of 25 is simply 5. So x is plus or minus 5. So there are only two values of x that satisfy this equation coming from the derivative being 0, and this equation coming from the points have to be points on the curve. Well, if you look for a point on the curve, you have to give an x and a y value. So what is our conclusion? Well, in the one case, x is negative 5. If x is negative 5, well, we know that both of these equations have to be true. Y must be 2x, and this equation must be true. Well, given that x is negative 5, the simplest equation that will allow us to solve for y is clearly not this one, but this one. So if x is negative 5, y is 2 times negative 5, hence y is negative 10. And if x is positive 5, y will be 2 times 5, positive 10. So we only have 2 points on the curve where the tangent line is horizontal. Right? This is our final answer. The first point is negative 5, negative 10. And the second point is positive 5, positive 10. So there you have it. The only 2 points on this curve where the tangent line is horizontal are the points negative 5, negative 10, and positive 5, positive 10. That's part 1. Let us answer now part 2. Part 2, we were looking for points where the tangent line was horizontal. Well, if you just go back at your derivative, a vertical, part 2 is vertical, a vertical tangent line, well, a vertical line has infinite slope. And the only way that this fraction will give us an infinite slope is if we divide by 0. Right? A non-zero number over a 0, 1 will give us either positive or negative infinity. So this has to be 0, hence 2y minus x must be 0. And remember, we're looking for points that are simultaneously giving us a vertical tangent line and points on the curve. So the equation of the curve must still be satisfied. So all values of x and y that satisfy this equation will give us points on the curve, and simultaneously this equation will give us points on the curve where the tangent line is vertical. Well, we can solve here for x equals 2y. So 2y is equal to x. And then what we'll do is we'll replace x by 2y in this equation, right? You could have solved for y and said y is x over 2, but then you would introduce fractions in the expression. You're better off leaving x as 2y and replacing x in here by 2y, and then you don't get any fractions. So this will make the algebra a little simpler. So we substitute. So what do we have? Well, x is 2y, so 2y all squared, minus x, which is 2y, times y, plus y squared equals 75. So what does that give us? Well, 4y squared minus 2y squared plus y squared equals 75. So we have 4y squared minus 2y squared gives us 2y squared plus y squared, 3y squared equals 75. Divide by 3, y squared is 75 over 3, as we've done before, that's just 25. And now y is plus or minus the root of 25. Therefore, y is equal to plus or minus 5. Well, once again, we now have only two values of y where the tangent line to the curve is vertical, at positive 5 and negative 5, but we need to have a point on the curve. So we need to find the corresponding x value. So y is equal to negative 5, y is equal to 5. And again, here you have two options. You could plug in the value of y in the equation of the curve, then solve for x. But you can do much simpler if you use the other equation, because x is simply 2y. So x here will be 2 times negative 10 times negative 5, hence negative 10. X will be 2 times 5, positive 10. And now we have our conclusion. There are only 2 points on this curve where the tangent line is vertical. The first point, and be careful here, is x is negative 10, y is negative 5. And the second point is x is positive 10, y is positive 5. And that's it.